Whole mathematical career, when you've, including this year, when you've dealt with angles, how do you measure an angle and what type of unit? There's only one unit you've measured an angle in, and that's what? Degrees. Well, that changes today. Okay, that changes today. There's a second way you can measure an angle, and that's called radians. All right? Every time in unit 8, 2 units go, I'd be like, make sure you're in degree mode, because sometimes everyone agrees it said RAD at the top. That's radians. All right, an angle can be measured in degrees and in radians. And we're going to start using radians today. We are going to start measuring an angle in radians. That doesn't mean a darn thing for your calculator. Leave this sucker in degree mode. Never change it out of degree mode for me, please. All right, but we will be measuring and using angles in what's called radians instead of degrees. First thing I need you guys to have the ability to do is go back and forth from one to the other. If an angle's in degrees, how do I change it into radians? If it's in radians, how do I change it into degrees? And lucky you guys, your calculator will do it all for you. Okay, you'll do it all for you. Here's how. So my first one is convert 30 degrees into radians. So maybe I have an angle that's 30 degrees, but I need it in radians instead. All right, how do I convert? Grab your calculators, everyone. Again, do not change your mode. Keep it in degree mode. So the first thing, I type in 30. Well, that's just the number 30, right? That's not 30 degrees. How do I tell the calculator I want 30 degrees and not the number 30? Everyone ready? Because this is a little bit of a process. You have your toolbox. Open up your toolbox. Keep scrolling down on your toolbox until you see units and constants. Open that up for me. Oh, look at the second choice, length and angle. So open up length and angle for me. Which one do you think we want if we're dealing with 30 degrees? Angle, right? So open up angle and look at all the choices that you have, including the first one, which is degree. All right, so please select degree, and your degree symbol should go right up to 30 degrees. Let me know if you're having issues here before I move on. So everyone has 30 degrees typed in right now. 30 degrees going. All right, go ahead. I'll do the same with you. Press enter. And really nothing happens, right? It just, oh, you want 30 degrees? Okay, there you go. I got it. Highlight that 30 for me. Go back up, highlight the 30, and everyone sees the 3 dots next to it? Yep, go to those 3 dots and look what pops up. Pi over 6 RAD. What do you think the RAD stands for? Radians. Yes. Now, you know how I roll. Do you think I really want you to write this whole long decimal and put radians? No. Leave it in terms of pi. All right. Leave your answer and leave your radians in terms of pi. So 30 degrees converted is the same as pi over 6 radians. Or if you want to write that decimal there, it's about half a radian. Right? 30 degrees is about half a radian. All right, one doesn't make us great. Let's keep going. Can you guys help me convert 45 degrees into radian measure? All right, same thing. Let's go back. So now I want 45 degrees. 45, and I think, tell me if I'm wrong, what's nice now is once you hit the toolbox, it'll go right back to where you were. So you don't have to keep scrolling and moving anymore. So 45 degrees. Enter. Highlight 45. Get your dots and see what it is in radians. You guys just living the life here. Have your calculator doing that. So pi over 4. And again, please leave your radians in terms of pi. I don't want to see you guys write that long decimal out. Any issues before I go the other direction? Any issues? All right, what if an angle's in radians, but you need it in degrees? All right, ready? Use the calculator. Let's go slow. Let me clear this out so we can all see. So I'm going to put in 7 pi over 6. But to your calculator, that's just 7 pi over 6. It doesn't assume it's radians unless we put radians next to it. So how do I tell the calculator this is radians? Toolbox. Go down to RAD for radian. So you tell the calculator it's in radians. And there shouldn't be a need to go to 3 dots here because your calculator automatically puts it into degrees for you. Wow. 210 degrees. One more time, 3 pi over 5. What's that in degrees? Again, I know some of you might just be in the habit of typing 3 pi over 5 and hitting enter and being like, where's my degree? That's not the degree measure, right? You've got to put radians next to it so the calculator knows you're in radians. Huh, unbelievable, this thing, 108. Last one I want to convert with you. Sometimes radians don't have to be in terms of pi. We just write it like that because it's neater. All right, we can write out the full decimal. So look at this next one, 3 radians. No pi next to it, it's just 3 radians. Convert it. So I go, same thing I've been showing you guys. All right, I'm just going to type in 3, make sure the calculator knows it's radians. And there it is. There's the number of degrees, just rounded. What did I ask you guys to round to? Nearest 10th, 100th, 10th? So what are we looking at here? 1.719. All right. 171.9, excuse me. Does everyone feel comfortable converting? Before we get to this next part. Ask away if you don't feel comfortable converting. Got to tell the calculator if you are degrees or radians, though, so please make sure those units are next to it. All right, somebody, who was it? Who gave me the arc length during the review? Who did? Who? Finley? Henry? Do it again for me. Here we go, Henry. Let's review from yesterday. Give me that arc length formula so I can fill it in here. Okay, relax here. Measure of arc, right? Over 360 times what there, Henry? Thank you. Times pi d. Perfect. Okay, we're going to run into a problem today. This formula can only be used if the angle's in degrees. You guys just found out sometimes that angle's not in degrees. What could it also be in? Radians. Yeah, so if it's in radians, useless. Okay, it needs to be in degrees for you to use this formula. So what happens if my angle's in radians? I'm going to give you a new formula today to find the length of an arc if it's in radians. All right, everyone okay with what I'm doing here? This can only be used if the angle's in degrees. You guys just found out there's a second way now, which is radians. So now I need to give you a new way to find the length of an arc if the angle's in radians. And here it is. Nice, simple formula, SOR. SOR. Literally. S equals, I'm going to put a Greek symbol here. Ready for this Greek symbol? Anybody know any Greek symbols? What do you got? I'm not looking for this one in particular, but what Greek symbol you got? Whoa, we got a hot shot back there. All right, what's a couple of them?
Symbols or like
just the names of them?
Alpha, beta, gamma,
delta. Okay, relax. All right, you got me there. All right, anybody? All right, I'm not even going to ask anybody else. You can't live up to that. Here's my Greek symbol that I'm using. Oh, not so great now, are we? Anybody know that one? No, I think that's the horseshoe.
Oh, there's the horseshoe.
Anybody? Know that one? Going? Last chance there, superstar. To show off.
I have an idea, but
Go ahead. You might be right. Does it begin with a T? Yeah, there we go. Theta. That's theta, the Greek symbol theta. and R. I call it SOAR. There's no A in that. All right, relax. All right, get off my back. All right, I know there's no A, and I call it SOAR. All right, but that's what it looks like. All right, so what does each piece mean here? Again, this is the formula I'm going to use if my angle is in radians and I need to find the arc length. Speaking of arc length, that's what S represents. S is the length of the arc. Arc length. Theta, my Greek symbol here, that's just going to be your central angle. That's your central angle measure. But hey, whoa. It can't be any central angle. It's got to be the one in what type of units? Radians, because that's why I'm using the formula. So make sure you make a note. It's got to be in radians. Okay, that's got to be in radians. And then I'll let you guys take what do you think R represents? Something we've been talking about. It's in a circle. Radius length, yep. So there are two formulas to find the length of an arc. One formula from yesterday if the angle is in degrees. One we're going to use today if the angle's in radians. So here we go with number one. Find the length of an arc. Everyone look at the angle. What type of unit is it in? My central angle, what type of units am I measuring it in? Radians. So I can't use this formula from yesterday because that has to be degrees. So I'm going to use S equals theta R to do it. That's the formula I use to find the length of an arc if the angle's in radians. All right, here we go. Go back to my notes here. So we're looking, what is that? All right, so S, length of an arc. Theta, what's my central angle in radians? Look at the diagram. What is my central angle in radians here? So many tabs open. Whoa, there we go. Bryson, what's my central angle in radians? Okay, so that gets put in for theta. Pi over 3 times, what's my R value now? My R value, Stephanie, what's my radius length? 5, good work. Multiply them, and the directions say round to the nearest hundredth for me, hundredth. Oh boy, how's our rounding here? How's our rounding? How's our rounding, Drew?
5.34.
I believe that is correct, if my memory is correct from first period. Again, you guys know how I feel. If you want to put centimeters on there, feel free. I'm not going to take off. We okay? Are you starting to see what we're doing today, which is, I can't use the arc length formula from yesterday because my angles aren't in degrees. So that's why I needed this new formula for radians. All right, next up, let's find arc length again. Find S. It's in radians, so that's why I'm using this formula. I don't want to use the formula from yesterday unless it's in degrees. All right, theta, the arc, the angle measure in radians. Angle measure in radians, what is it here? What's your central angle for this one? 1 zip. Henry, back to you back there. 94.25. All right. I guess we got superstars back in that group, huh? I just wanted to know the central angle, Henry. That's it.
10 pi divided by 9.
Thank you. Yep. Thank you. And I'm just going to say radius of 27. All right, Henry, go ahead. Now you could show off.
94.25.
Questions? Ask away here. Are we okay on what we're doing? Why I need another formula? Because sometimes the angle's in radians, and I can't use the formula from yesterday if it's in radians. I got to use this S equals theta R if my angle's in radians. Because I'm going to use this formula differently right now. All right, here we go. Now I want you to find theta. All right, find the angle. All right, find the central angle. and we're going to do it in radians, and then we'll talk, well, how do I find that same angle in degrees? But let's find it in radians first, because that's the formula we're using today. Let's find this angle in radians. So S equals theta, and that's just a variable, times R. I have something to plug in for S now. S is the arc length. So look on your diagram. What is the length of an arc that belongs to that angle we're finding? What's the arc length in this one? Ooh, Alyssa, what's the arc length? There you go, everyone. That's going in for S. Perfect. Equals. We're finding the angle theta. Leave it theta with a radius of 16. How do I get the 16 out of there so I know what the angle is? Get the 16 out of there so I know what the angle is. Ooh. Finley, how do I get the 16 out of there? Good job. So everyone divide. I'll go to my calculator with you guys to do this. So theta equals, all right. Let me go to my calculator way over here. Ready? 8 pi divided by 16. All right, there we go. And which one do you think I want if we're looking for the angle in radians? I don't want that long decimal. You can write that long decimal and put radians next to it, but I prefer the pi over 2. All right, so this will be, that angle is pi over 2. And you can put radians next to it, but since we know you're using this formula, it's already in radians. All right, pi over 2. How do I get the degree measure? Calculator, convert it, right? Calculator, convert it. So everyone, pi over 2 radians, and convert that thing into degrees, and I'll ask somebody, what do you get in degrees? Where am I going here? All right, pi over 2 in degrees, same as when you have it, Vinny, what do you got? 90 degrees. Good work there, young buck. Perfect. We okay? Again, you are only using SOAR for radians. All right, radians only. All right, next up. Here we go. Again, going to find that angle measure. Again, I always start with radians because this formula is so darn short. The other one from yesterday is a little bit longer. I just use this one. If you're using this one, you're finding radians. Arc length, plug it in for me. Let's get a roll now. Stephanie, arc length. All right, plug it in. Theta, and we got R as 5. All right, we had some issues in first period plugging this into our calculator, so make sure you can do this. Divide both sides by 5, right? Make sure you can do this. We had a couple issues first period. 15 pi over 7 divided by 5. Make sure that's typed in correctly, because we did have a few issues, and if we do here, I just want to clean them up quick. So make sure 15 pi over 7 is on top and 5 is on the bottom of your fraction. All right, so 15 pi over 7 on top of your fraction, 5 on the bottom. What are you getting in radians in terms of pi? Radians in terms of pi. Stephanie, oh geez, going back to you. Whoa, 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 whoa. You're giving me degrees right now. I just want, you can start joining that group there. What do you got? 3 pi over 7, good. And now change that into degrees. Please put the word radians next to it when you convert it, right? Because your calculator will have no idea you're talking about radians unless you put it next to it. In degrees, part of it was given away. Micaiah, what do you got back there? 77.14. There we go. I know I didn't have rounding directions, but I'll keep that 100th. All right, are there any questions or concerns here between both formulas? One is reserved for degrees. SOAR is reserved for the angle in radians. All right, 3 more to go. I'm going to change it up here on a bit. I got to make you read. Sorry. Find the diameter. Oh, diameter, huh? That's a first today. Well, first, I need somebody to answer a question here. Let's see. Henry, back to you. Oh, I thought we were just going to answer it without me even saying anything. But my angle. What type of units am I measuring my angle in here, Henry? Radians. So that automatically tells me, here's the formula I'm using. Maybe. There we go. Okay, there's the formula I'm using because it's in radians. Wait a second. Whoa. Wait a second here, smart kids. They're asking me for the diameter. This formula doesn't have diameter. Should I go back to the other one then? Because that one has D. Or can I still do it here? This one doesn't have diameter. Am I stuck? What can I do here? It doesn't have diameter. Oh, help out. Need some help. Need some help. Need some help. Cormac needs some help. This problem's asking for diameter, right?
Yeah.
But my formula only has radius.
Yeah, we still use it.
Oh, how?
Just gotta substitute in the S and
What do you want me to solve for?
solve for the radius.
Oh, and then do what at the end?
Multiply by
Okay, everyone good? I do not need to go back to the other formula. We can just solve for the radius and we know it being multiplied by 2. There we go. So let's see. What's going to be plugged in for S here now? What is my arc length already? Finley, arc length? Good, 24.5. Theta, angle, 3.5 times my radius. Good job, everyone. Good job. When you have that radius length, let me know. Keep plugging away. I know I'm going quick here. Keep plugging away. Oh, Micaiah, back to you. Do your thing. 7. Oh, nobody said. You didn't say that. You all right back there? What do you keep typing in your calculator?
I'm just not getting that answer.
What do you got to do on both sides? By what? Yeah, 24.5 divided by 3.5. Everyone all right? 7? That's the radius. Cormac, what'd you say at the end? I need diameter, though. Double it. Yep. All right, ready? Oh, boy. Oh, boy. Pendulum. Do we have to go over pendulum? Anybody familiar? We good? Pendulum. You can even get creative here. We found this last period here, this cute whale here with the little crab as the pendulum, or the little life raft, if you want, as the pendulum. $54, waste of money. There you go. There it is. How about that? Whale pendulum clock with the little crab. That's cute. Oh, look, you can. Oh, I thought there was different ones. Usually, oh, there they are. Yep. Look at this, kids. Look at, we got the gorilla there. Yep. We got the cloud with the sun. Little octopus submarine. Beautiful, huh? You know what all these have in common? Something that will never be put on my wall at my home. Okay, that is embarrassing. Okay, so if anybody has $54 you want to throw away, there you go. You get yourself a cool clock with a nice little pendulum. All right, not at the Carlino residence. All right, anyway, so everyone's good with the pendulum. We're good? Swings through an angle of 2.5 radians. Right? Radians. What's that going to be then? What am I going to plug that in for? 2.5 radians. What's that going to get plugged in for? That's my theta, right? That's going to be theta. and it travels through an arc of 50 centimeters. Where's the 50 going to get plugged in for? 50, an arc length of 50. That's S. Good. Now here's what I want you to focus on. Find the length of the pendulum. I didn't use the word we've been using all day. Pendulum. The pendulum here is the same as what? Finding. Yeah. Get used to that. Sorry, sometimes I'm not going to use the vocabulary term. I'll try to put it as a real life example, right? Radius, because we all use pendulums. All right, radius is the same as the pendulum. All right, let's set it up. S equals theta r. $50. Theta, we said the radians was 2.5, and we're solving for the pendulum length. All right, so all I wanted to do in this problem was to get you guys, hey, I may not use to say find the radius. I'll use a different term, pendulum. That's the same as the radius. And how long is this pendulum here? Where am I going? Jared, how long is that pendulum? 20, yep. Centimeters. One last look. We're good. And I probably shouldn't be knocking it and making fun of it because I don't know, does anybody have one in their house? Good, because I would tear you, I'd rip you apart too if you had. All right. Yeah, Mr. Carlino, I have the octopus. All right, well, you need to reevaluate your life. Okay. All right, might as well just wear pajama pants. All right, we ready? Number 7, too far. Some of you just hit home. Sorry. All right, suck it up. All right, last one. Go ahead, read through this one. We're finding the length of arc AB, and notice how I got detailed, because you could say which arc AB, Mr. Carlino, and you'd be right, but notice what term I'm using. Minor arc from the other day. So that means I'm looking for the arc that's less than 180. So this one right here. All right, we're looking for the length of this one. All right, let's see if I've really done a decent job here. Why can I not use S equals theta r here? Yeah, you better not be plugging 165 in for theta. Right? Everyone see how this comes now. That theta is only used for angle measures that are in radians. This is in degrees. So whoa. You have two options. You could take 165 in your calculator, convert it, and then use S equals theta r. Or what I'm going to do right now is we can use the formula from yesterday. You guys blaze your own path right now. All right. If you want to convert it and use S equals theta r, convert it. If you want to use the formula like I am from yesterday, go right ahead. I'm going to use measure of the arc over 360 times pi d. But hey, if you want to go to your calculator, take 165 degrees, convert it into radians, and then use SOAR, go. We're both going to get the same answer. All right, we're going to get the same answer. You guys that are using the formula from yesterday, like I am, be careful. Do I want to plug 2.4 in for D? No, I want to plug in 4.8. Excuse me, 4.8 in. And we're rounding to the nearest tenth of a meter. So I'm hoping a couple of you guys are using SOAR and get the same answer as we are, hopefully. So I'm hoping some of you guys in the group here converted it to see if you truly do get the same answer. But again, only use SOAR if it's in radians. When you do have that answer to the nearest tenth, let me know. Oh boy, here we go, Drew. Back to you.
Which one?
What do you mean, which one? I don't care what you used. You should get the same answer. If you use the one from yesterday, or if you use SOAR, we should both be getting the same answer. It's not a which one here.
Yeah, 3.5.
What'd you use?
Agreed.
Okay, so you did 165 over 360.
did radius instead. Diameter.
Okay, that's fine. So what did you need to do to the 2.4? Okay, so you should have 4.8 in there. All right, get after it now, please.
6.9.
There you go. Thank you. Meters. No? Stephanie, all right? What formula did you use?
I used the one from yesterday.
Okay, so the one we have up here,
Yeah.
and you have 165 over 360, right? Make sure everything's tight. Up, user error. Yep,
Yes, yeah.
it's all right. Keep it to yourself. We don't, we're good. Anybody else? Okay, let's see if I can do this in 3 minutes. Help you with the first problem from the homework tonight. Oh boy, the old clock. Let's see if I have enough time to do this. All right. So it's asking from 1 to 9, how many degrees and radians does the hour hand, the shorter one, everyone, right? The shorter one, the hour hand travel from 1. So it's going from here and it's going to end up here from 1 to 9. That's what I want. What is this angle right here in degrees and in radians? And I gave you a little bit of a hint. What was the hint I gave you? 1 minute. Every time it travels 1 minute, it goes how many degrees? 6. That's what it says on my hint, right? So remember, there's always 1, 2, 3, 4, right? 1, 2, 3, 4, 1, 2, 3, 4. I'll stop right there. So every time this goes 1 minute, it's going 6 degrees total. This is where the confusion comes in. How many minutes is it from 1 all the way to 9? How many minutes am I going? Well, how many minutes am I going from 1 to 2? Don't tell me 60. You're not going all the way around. You're just going from here to here. How many minutes am I going? Minutes. Aren't I going 5 minutes? 1, 2, 3, 4, 5 minutes it's going to travel? Yes? So that's how many degrees? 30 degrees. Right? So this will be 30 degrees. Every time it travels, you guys are thinking it's going all the way around. That's not what I want. It's just going to go from here to 9. All right, so every time it goes 5 minutes, it goes 30 degrees. Add them all up, find out how many degrees you have, and then convert it into radians the best you can. All right, everything else should be fine, though. Everything else is arc length. And I don't have the answer for this on the key. I want to see what you guys come up with. The rest of them are on